If you look at the template, we'll go through this first and then we'll do an example. Looks like this. With bold words. Okay, so first of all, the purpose of optimization is to maximize or minimize something. So trying to maximize profit, minimize cost, those kind of things. Okay, so just looking through the template. Number 1 says, what are we trying to maximize or minimize? So we're just going to write down maximize area of a circle, or whatever we're trying to do. Then it says we need to write a function for that quantity in terms of one or more variables. So if you write the area of a circle, what is the area of a circle? Pi r squared. That's what you would write. Or whatever formula we're using, we would write that down in terms of however many variables it has. Step 2 says to write the above function in terms of one variable. This is the hard part for optimization. The hard part for related rates was coming up with a function or a relationship. The hardest part for optimization is putting that in terms of one variable only. So typically you're going to use a relationship in the problem. So they're going to give you some relationship that will help you put it in terms of one variable. Sometimes you have to use geometry. Sometimes you have to use a figure. I don't know. There's different things, but sometimes they'll just give you the relationship. Step 3 says, what's the domain? I know that in previous years, your teachers have probably just sort of brushed over domain, right? Kind of talk about it every once in a while. I do the same thing, I should just say. However, domain is really, really important, and I've tried to stress that to you more this year. Is that it's really important. What is your domain? Because take x squared. X squared and x squared only from 0 to 1, those are two really different things. So the domain makes the function. It's not just x squared. I mean, the properties of the function come also from the domain. So it's really important. Also, when we get down to step 5, we'll come back to why domain is important. Okay, step 4 says find the critical numbers for the function. How do we find critical numbers? Yeah, set the derivative equal to 0 or when it's undefined, right? That'll give us critical numbers. Okay, number 5 says justify our absolute max or min. If we're on a closed interval, we can use the candidate test or the closed interval test. So that's where domain's important. When you look at the domain, if you realize that it's a closed interval, then all you need to do is use closed interval tests. If you look at the domain and let's say it's an open interval, which is going to be more likely than not, then we can use first or second derivative test. It says, if not, use the first or second derivative test to justify a local max or min. So remember that those tests only, this is sort of a review for those of you who haven't taken the test, those tests only give you relative or local maxes or mins. But we're talking about absolute max or min, right? We're talking about maximizing profit. We want to know the absolute max, not some sort of relative max. Once we find or justify the local max or min, then we have to argue our way to an absolute max or min. The easiest way to do that, the way almost every single problem is going to be in here, is you're going to say that there's only one critical number. So if we think about critical numbers, they could also be called turning points. So if we're going up and we have one turning point, then that has to be the absolute maximum. If we're going down and we only have one turning point, then that has to be the absolute minimum. Do you see what I'm saying? Okay, not one max or min. So you can't say because there's only one relative max, it has to be the absolute max. Here's why. This only has one relative max. Is it the absolute? No, definitely not. So that would be not true if you said that. Now, you could say because it only has one critical number. It only has one place where it's going to turn. Does that make sense? Okay, this one obviously has 1, 2, 3 critical numbers, not just one. Okay, so we have to be careful with that. If you want to go ahead and write that in under 5, the little star, asterisk, highlight something, that you can argue your way to absolute max if there's only one critical number, or absolute extrema. And then 6 says answer the question. So make sure that you don't do a whole bunch of good, great work to not answer the question. You want to make sure that you are doing that. Let me zoom in. Okay. Let's look at the paper that says December 4th and 5th, Module 1. The first example says a farmer has 2,400 feet of fencing and wants to fence off a rectangular field with one side along a stray river. What are the dimensions of the field that has the largest area? We're going to work through the template. Step 1 in the template says, what are we trying to maximize or minimize? And what are we trying to maximize or minimize? Maximize area of a rectangle. I like for you to put the shape, because if you don't, there may be more than one shape in a particular problem, and you may start right off the bat wrong. So we want to write exactly what we're trying to maximize or minimize. Maximize area of a rectangle. The next thing on the template says, write an equation for that. What is the area of a rectangle? Length times the width. I'm also going to draw a picture. So here's my river. Here's my 3 sides. That's a horrible rectangle, but I think you understand what's going on. Now, I've got to label this somehow. So what do you want to label length and width as? L and W. So let's call this one L and this one W. Will that work? So label it somehow. Let's say here you had chosen to use okay. Let's say here that you had chosen to use X and Y instead. It's fine, just to label the variables. Okay, so that's number 1. Step 2 says to write this in terms of one variable. And like I said, a lot of times they're going to give you a relationship in the problem to help you do this. What do they give you? You have 2,400 feet of fencing. So looking at our picture, how would we write that in math form? Yes. 2W plus L equals 2,400. This is where the fencing is going to go. The fencing is not going to go on the river. It's its own natural boundary. So we'd have 2W plus L equals 2,400. Okay, now I'm using this relationship to get it in terms of one variable. So I'm going to solve for L just because that one seems easier. So 2,400 minus 2W is what L is equal to. And then I'm going to plug that in. So I get area equals length times width. At this point, I'm not going to simplify. I'm always just going to leave it like it is. And this is where I'm going to tackle the domain issue, because the domain question will be a lot easier to answer in context. So first of all, I see that my variable is W. So I'm asking, what are the possibilities for W? Looking here and looking at the picture, I'm going to look at both of these things and figure out what are my possibilities. So you tell me what you think. Between 0 and 1,200. W has to be bigger than 0 because we can't have a negative distance or negative length. A lot of students think that it should be 2,400. But look at, in terms of our pictures, we have to have 2 of those. So if this, can W be 1,500? Can this side be 1,500 feet long? No, it's not possible, right? It has to be 1,200, or it has to be less than 1,200. Make sense? Okay, awesome. That's why there's no equal sign here. W can't be 1,200, but it can be like really close to 1,200. Okay, that's step 3. Notice that we have an open interval, so we're going to use first or second derivative test for this. Step 4 says find the critical numbers. So this is where I am going to simplify. A is equal to 2,400W minus 2W squared. A prime is equal to 2,400 minus 4W. What's my critical number? 600. Okay. Now I'm going to use second derivative test here just because it's easy. Second derivative is -4. And I can say, since a prime of 600 equals 0, remember if you're going to use second derivative test, this is also good review. If you're going to use the second derivative test, you have to say that the first derivative is 0 and whatever the second derivative is. So since the first derivative at 600 is 0 and the second derivative at 600 is negative, less than 0, because that's how we found it. That's how I found the critical number. Is we found where is the derivative equal to 0? 600. We know the second derivative is -4 because if we just take the derivative of the first derivative, we get -4. So since the first derivative at 600 is 0 and the second derivative at 600 is negative, there is an absolute max, or excuse me, a relative max. Please don't write absolute. There's a relative max at W equals 600. Now we've justified, we could say by the second derivative test if you want. You should write it out. I'm just shorthanding it here. So we've justified that it's a relative max. Now we have to argue our way to an absolute max. So we could say the absolute max is at W equals 600 because there's only one critical point on the domain. Or in the domain. You could also say critical number. So again, since the first derivative is 0 at 600 and the second derivative is negative at 600, there has to be a relative max at 600 by the second derivative test. Then that's fine, but in this justification you're going to have to say the derivative changes from positive to negative or negative to positive or whatever happens. Actually, all you need for the first derivative test is that the derivative changes from positive to negative or negative to positive. You would have to test it. So once you find the critical number is 600, you have to test something to the left of 600 and something to the right of 600. That is in the domain. Another reason why domain is important. So we justified here by the second derivative test that it's a relative max, and then we said it has to be where the absolute max happens since there's only one critical number, or critical point, or whatever you want to call it. Okay, so we've justified that. This was step 5, and then step 6 says answer the question. What's the actual question? What are the dimensions? So notice that we've done all of this work. It's beautiful, it's great, it's right, but we still haven't answered the question. So make sure that you answer the question. The dimensions are going to be W equals 600 feet. And what does that make length? 1,200 feet. Make sure you put feet also. And it should say on the template, if you want to write this in, it should say answer the question including units. Questions on this? Okay, for homework, I want you to try the first 2